I'd like to show you another construction that I think is kind of clever that one of my students came up with for constructing a rectangle with side ratio 2:1. So the students started out by constructing a square inscribed in a circle. So let's make that first. Okay, there is circle A. Okay, and I'm now going to inscribe a square with a construction. So first let me draw a diameter. And let me call this L and M. Now I am going to create the perpendicular bisector of LM that goes through A. So let me extend this a little more than half the way and make that arc sweep. Without changing the compass radius, I will now set the compass point at L and make a second sweep. And what I'm looking for are these two intersection points so that I can draw in the perpendicular bisector of the diameter LM and find this point on circle A and this intersection point on circle A. We can call that LM and O. Now I can finish drawing in my square. Students like to do the inscribed polygons, including squares, so I understand why the student thought of this. So we have a square, and the problem was to construct a rectangle. Well, square's a rectangle, but the sides are in a 1:1 ratio, and they need to be in a 2:1 ratio. So what the student just did next was extend this side and extend this segment, and using LO as the ratio of 1, this is already in a ratio to 1, so once they find the length of the square of LO, which is the same as OM, they can just mark two new intersection points. Let's call this X and this Y. This can be a strangely named rectangle. But we now have rectangle, what do we call this? LXY0 or O, LXYO. LXYO, and it has a ratio 1:2 or 2:1.